Good afternoon, everyone. Today we are going to master one of the most heavily tested and clinically important topics on the BCBA exam, reinforcement schedules. Our focus will be on fixed ratio, variable ratio, fixed interval, and variable interval schedules. But rather than memorizing definitions, we will analyze the logic behind each schedule, understand how they shape behavior, and learn how to identify them from graphs and clinical scenarios. By the end of this presentation, you should be able to interpret response patterns, predict extinction resistance, and select schedules strategically in practice. Let's begin with why reinforcement schedules truly matter. Reinforcement schedules are not just theoretical constructs. They directly determine response patterns. On the BCBA exam, schedules frequently appear in graph identification questions and applied scenarios. You are often asked to determine the schedule based on response rate, pauses, or pattern shape. Clinically, schedules influence acquisition speed, fluency, and maintenance. For example, ratio schedules generally produce higher response rates, while variable schedules increase resistance to extinction. So the key principle is this: schedules shape behavior patterns. With that foundation, let's clarify the core concepts we must master. Today we will structure our understanding around 4 core distinctions. First, continuous versus intermittent reinforcement. Second, ratio versus interval schedules. Third, fixed versus variable arrangements. And finally, how these combinations produce predictable response patterns. You should visualize these schedules as 4 quadrants: FR, VR, FI, and 6. Instead of memorizing isolated facts, we will analyze how each dimension affects behavior. To do that effectively, we must begin with a precise definition of reinforcement itself. Before we go further, let's clarify reinforcement. Reinforcement is a behavioral process in which a consequence increases the future frequency of the behavior that produces it. 3 elements are critical here. First, reinforcement is contingent on behavior. Second, it functions by altering future probability. Third, it is defined by effect, not by form. This aligns with operant conditioning. Behavior is controlled by its consequences. If behavior does not increase, reinforcement did not occur. Now that we understand reinforcement conceptually, let's examine how often it is delivered. Continuous reinforcement, or CRF, means every response is reinforced. It produces rapid acquisition and is ideal when teaching new skills. Intermittent reinforcement means only some responses are reinforced. This produces greater behavioral durability and resistance to extinction. A common exam trap is confusing frequent with continuous. Continuous means every response, no exceptions. Clinically, we typically begin with dense reinforcement, then thin to intermittent schedules for maintenance. To understand how thinning works, we need to explore the 2 structural dimensions of schedules. All reinforcement schedules are built from 2 dimensions. The first is ratio versus interval. Ratio schedules depend on the number of responses. Interval schedules depend on the passage of time. The second dimension is fixed versus variable. Fixed schedules are predictable. Variable schedules are unpredictable and typically produce greater persistence. Combining these dimensions yields 4 basic schedules: FR, VR, FI, and 6. Let's examine each one carefully, beginning with fixed ratio. A fixed ratio schedule delivers reinforcement after a set number of responses. For example, FR 1 reinforces every response. FR 5 reinforces every 5th response. FR schedules are highly effective for building new behaviors and increasing fluency. However, they produce a distinct pattern: a post-reinforcement pause followed by rapid responding. This predictable requirement creates a repeated cycle of pause and burst. This brings us to the characteristic FR response pattern. Fixed ratio schedules produce what is often called a break-and-run pattern. Immediately after reinforcement, responding pauses. Then the learner emits a rapid burst of responses to complete the next ratio requirement. Graphically, this appears step-shaped. The key exam clue is the pause after reinforcement. Whenever you see high responding with predictable pauses, think fixed ratio. Now let's compare that with a schedule that produces even higher and steadier responding: variable ratio. Variable ratio schedules deliver reinforcement after an average number of responses. Because the requirement is unpredictable, the learner cannot anticipate when reinforcement will occur. This produces very high, steady response rates with minimal pauses. A classic example is gambling. Slot machines operate on variable ratio schedules. VR schedules produce the highest response rates and the greatest resistance to extinction. Let's explore why that resistance is so strong. Variable ratio schedules are the most resistant to extinction. When reinforcement stops, behavior maintained on VR decreases more slowly than behavior maintained on any other schedule. The unpredictability strengthens persistence. In comparison, 6 shows moderate resistance. FR shows moderate resistance. FI shows the weakest resistance. If an exam question asks which schedule is hardest to extinguish, the answer is almost always VR. Now let's shift to time-based schedules, beginning with fixed interval. A fixed interval schedule reinforces the first response after a fixed amount of time has passed. For example, in FI, 5 minutes, reinforcement becomes available after 5 minutes, and the first response after that interval is reinforced. Learners quickly detect the timing pattern. They pause after reinforcement and then gradually increase responding as the interval ends. A common mistake is assuming FI produces steady responding. It does not. Instead, it produces a very distinctive pattern. Fixed interval schedules create a scalloped response pattern. Immediately after reinforcement, responding is low. As the next interval approaches completion, responding accelerates. Graphically, this looks like repeated curved increases, like scallops. The predictable timing drives this acceleration. If you see low responding followed by gradual acceleration before reinforcement, think fixed interval. Now let's compare that to variable interval. Variable interval schedules reinforce the first response after an average time interval. Because timing is unpredictable, learners cannot anticipate reinforcement. This produces moderate, steady responding with minimal pauses and no scallop. 6 schedules are more resistant to extinction than FI schedules, but not as resistant as VR. On exams, remember, 6 equals steady but not the highest rate. Let's summarize the response pattern more clearly. Variable interval schedules produce smooth, moderate response rates. There is no scallop because timing is unpredictable. There are minimal post-reinforcement pauses, but the response rate is not as high as VR. Think of 6 as stable and steady. Now that we understand each schedule individually, let's compare them directly. Ratio schedules are response-based. Interval schedules are time-based. Fixed schedules are predictable. Variable schedules are unpredictable. FR, set responses. VR, average responses. FI, first response after set time. 6, first response after average time. Understanding these structural differences allows you to logically derive response patterns rather than memorizing them. Now let's rank them by response rate. Variable ratio produces the highest response rate. Fixed ratio produces high responding, but includes pauses. Variable interval produces moderate responding. Fixed interval produces the lowest overall rate due to post-reinforcement pauses and scalloping. If you see continuous high responding with no pauses, think VR. Now let's compare resistance to extinction. In terms of resistance to extinction, the ranking is VR, strongest. 6, moderate. FR, moderate. FI, weakest. Variable schedules generally produce greater persistence than fixed schedules. This is a major exam principle. Next, let's examine how these schedules appear in test questions. Most schedule questions fall into 4 types: graph identification, scenario analysis, response rate comparison, extinction prediction. Look for pattern cues. Step-shaped equals FR, smooth and steep equals VR, scalloped equals FI. Use structure and logic rather than memorization. Now let's apply this clinically. In practice, we typically begin skill acquisition with CRF or FR1. As fluency develops, we may shift to FR schedules with larger ratios or transition to VR. For maintenance, 6 schedules often resemble natural reinforcement contingencies. The key principle is matching the schedule to the learning stage. This leads to reinforcement thinning. Reinforcement thinning begins with dense schedules and gradually transitions to intermittent schedules. Abrupt thinning can produce ratio strain and behavior drop. Therefore, changes must be gradual and data-based. Always monitor response rate during schedule transitions. Next, let's discuss strategic schedule selection. If your goal is teaching new skills, use FR. If your goal is building fluency and persistence, use VR. If your goal is long-term maintenance, use 6. The schedule you select directly shapes response rate and resistance to extinction. Now let's consider common implementation errors. Common mistakes include thinning too quickly, using interval schedules for new skill acquisition, and failing to monitor response rates. Schedule changes without data can lead to behavior reduction. Measurement is essential when adjusting reinforcement density. Finally, let's review a decision-making framework. When analyzing a question, first ask, is reinforcement based on responses or time? If responses, ratio. If time, interval. Then ask, is it predictable, fixed, or unpredictable, variable? Finally, match the schedule to the behavioral goal. This structured approach prevents common exam traps. To summarize, schedules shape response patterns. Variable schedules increase persistence. Ratio schedules produce higher response rates than interval schedules. Time-based schedules produce distinctive acceleration patterns. If you can identify the response pattern, you can identify the schedule. That is the key to mastery. In conclusion, reinforcement schedules are not simply definitions to memorize for the BCBA exam. They are functional systems that shape response patterns, determine persistence, and directly impact intervention outcomes. When you truly understand how fixed and variable, ratio, and interval schedules interact, exam questions become logical rather than intimidating. But mastery does not come from passive review. It comes from application. The best way to solidify this knowledge is to practice identifying patterns, analyzing graphs, and reasoning through scenario-based questions under realistic testing conditions. If you are serious about strengthening both your conceptual fluency and your exam readiness, I encourage you to continue practicing through full-length mock exams and structured schedule drills. You can find additional practice materials and a free full-length BCBA mock exam at bcbmockexam.com. Because understanding reinforcement schedules is important, but applying them accurately is what truly defines mastery. Thank you.